Hey everyone, welcome back. So in this video we are going to understand this Leetcode problem, right? And this question is very important because this question based on multiple concept in the program, right, that we are going to solve. So the problem is based on the tournament, right? So the question is saying that there is a tournament and players are participating. The players are standing in a row, single row, and are numbered from 1 to n based on their initial standing position. So player 1 is the first player in the row, player 2 is the second player in the row, and so on, right? Means the player will be standing in the ascending order 1 2 3 4 5 6 7 like that. Okay, so the tournament consists of multiple rounds, right? We know that there is multiple rounds, right? So starting from the round 1, in each round, right, ith player of from the front of the row competes against the ith player from the end of the row. Let's suppose we have 10 players there, right? So the first player will play with the 10th player. Okay, so he's saying the winner advances the next round when the number of player is odd. For the current round, the player in the middle, right, automatically advances for the next round. Let's suppose we have given the player and they are standing in a row 1 2 4 6 7. So these are player. So these are the player, consist of this player, we can say like this, right? So player 1 competes with 7, right? The first player will compete with the last player, correct? Now second player will compete with the second last player, right? And 4, we don't have any other player to compete with, so what will happen? Player 4 will automatically advances to the next round, right? So these are the concept it is saying, right? Now it is also saying after each round is over, the winner are lined up back in the row based on the original ordering that is assigned to them initially in the ascending order. So the player number first player and the second player are the best in the tournament. They can win against any of the player before they compete against each other. So if two player competes against each other, either of them might win. Thus you may choose the outcome of this round. So we have given the player integer n, first player, second player, right? Like that we have given. So we have to return an integer, right? We have to return an integer array that contains, right, two values. The first value is the earliest possible round number, right? And second, the latest possible round number in which these two players will compete against each other, right? Let's suppose, as per the example we have given, in example 1 it is saying that we have input n, means 11 players are there, and player 2 and player 4 are the first and second player who are strongest in this tournament. Okay, and so we have to return an array that contains what? The first 3 is the earliest possible round number we have, and 4 is the latest possible round number in which these two players have competed, right, against each other. Okay, so these are the things that we have given that we will discuss further in this video. So let's understand. So let's understand here. So if we will summarize this problem, right, the problem is saying that we have given n players, we have given, that is number from 1 to n, can we say that? And the first player and the second player are the two strongest player we have in the tournament, since they always wins against any other player in the tournament, right? Until they face each other, they can win. Means player 1, like first player and the second player, who are the topmost two player or strongest player we can say in the tournament, they can compete with each other until they are not coming to face each other, right? So we can say first player and the second player are the best player in this tournament. So this concept we have to also take care. Next it is saying that at each round, let's suppose we have match, so ith from the start vs ith from the end, can we say that? So we have to play like this, as we have understood, right? So winner will proceed further for the next round. If odd number of players are coming, let's suppose 5 players are there, right? So the first player and the last player will play. Left is 3 player left, right? Then second player with the second last player, right? Only one, the middle one, third is left, right? So if the odd number of players we have, right, so the middle player gets a bye. Can we say that? After the round, winners are sorted in ascending order. Can we say that? Means after the round, winners are sorted in ascending order again, right? And then we have to repeat these things, right? At each round, as we can say that this round we have to check. We have to find the latest, earliest and latest possible round number in which first and the second player face each other. Understand? So it means you have given the total number of players n, right, which is numbered from 1 to n, not from 0 to n, right? This is n players, so player will start from 1 to n. So two player, the first and the second player, they are the best player, we can say, and they are the strongest and can defeat anyone except each other. So all other players can win or lose randomly. Can we say that? So how the tournament works? Let's suppose we have players and that they are lined up in a row like this, right? So player 1, 2, 3, 4 and 9, 10 as like this. They have in a row. They are standing like this, right? For example, because n we have given is 11, let's suppose. So there is 11 players are there. Can we say that? So the match rules per round, how will work? How gonna it work? So the first player fight the last. Can we say that? Means this first player will play with the last. So we can say the first vs 11, right? Can we say that? 1 vs 11, we can say that. The second fight will happen where the second last, means left is these 2 and this 10. So 2 and 10 will fight. Remaining is 3 to 9. Next third round will fight 3 and 9, right? So will 3 and 9, and so one will do 4 and 8, 5 and like this, and will keep going that, right? So until we'll finish the all of them. Can we say that like that? We will go, means 1 11, 2 10, 3 9, 4 8, 5 6 7, like that we will go like this. Can we say that? And if there is an odd number of players, so the middle one automatically move to the next round and will say gets a bye. So after each round, right, the winner are resorted in ascending order, right? This is the tournament game. So what is our goal? We have to find like in which round do player and player first and player second compete, right? What is the earliest round this can happen, and what is the latest round this can happen? Can we say that? Means we have to return it in an array. Let's suppose we call this resultant array, and this resultant array will store the very first index, that is index 0, earliest round, and the index 2 will store the latest round. I hope you understand the problem, right? So let's understand through an example where n is equal to 5 and we have the first player is 1 and the second player we have is 5. Now let's line up the you can say employees, right? Let's suppose we'll start from 1 2 3 4 and 5. So these are the players, right, that they are going to play here, right? So we have made them line up. So player 1 so round 1 we are doing pairing. Let's suppose this one will compete with 5, 2 with 4, and 3 doesn't have anyone, so he will get bye. Can we say that like this? So player 1 and player 5, this is the first player and this is the second player. Can we say that? As we have given here, the first player is first player and the second player is the fifth player, right? And they are playing here in the first round itself, right? And these are the pairs that we have talked about. So they meet in round 1. Can we say that? They meet in the round 1, right? So we will pass 1 and 1, right? Because this is the earliest and this is the latest, right? And that is called round 1. So we'll return like this. I hope you understand. Now see another example where n is equal to 11 and the first player is 2 and the second player is the fourth, right? Means this is the second player, right? And the fourth is a what we call second player, right? So in the very first round we'll go with what? 1 vs 11, as we know, this and this, then 2 and 10, like this we will do. So 1 vs 11, 2 vs 10, 3 vs 9 and 4 vs 8, right? And 5 vs 7, and in the first round 6 will get the bye because there is no other candidate to fight, right? So they don't meet in the round, right? Because we haven't seen in the first round. In this round they don't meet, the first player and the So the first player and the second player have not what we call fight with each other in this round, in the round 1. So now the winner go to the round 2 in an order, right? So the lineup now depends on who won the matches, right? 1 vs 11 and etc, so that we have given, right? So since all others are random, we simulate all the paths until 2 and 4 meets. We'll keep repeating that, right? So in some cases they meet early, let's suppose round 3, and other in round 4. So we'll say early is 3 and next round is 4. So they have meet in 3 and 4 also. So let's suppose how I'm saying that, let's suppose the players we have that 1 2 3 and we have written like this, right? So very first player is here and the right player is, let's suppose, here, right? So player 2 and player 4 are the first player and the second player, and they're the strong and they will win any matches unless they face each other, that we know, right? So we'll do the pairing, we'll know how to do the pairing, right? The ith from the front and the ith from the back. Can we say that this and this we can say? I should put here, I think, okay. So just think that I have put here, right is at 11, okay? So 1 vs 11 will do, and 2 vs this, what will happen? Who will win? Let's suppose first player is here, so first player will win, right? And will get 2 wins here. Can we say that? 4 and 8 means player 4 will win, right? So 4 wins here, right? So total is this one, and say in the last we have 6 advances, so middle, and the rest of the other random. Who will win? God knows, right? After this round, winner, because that is a random, that is I'm saying the God wins. After this round, winner advances. Assume that strong players have win 2 and 4, right? That is a win, and random other player, suppose 1 3 and 5 win. Just God knows, right? 1 3 and 5. So the next round, if we'll do the lineup, 2 4 will be there, right? And rest of the these will be there, right? So these will be put like this, right? And 6 we have already put here. So sorted after each round, this will look like this, right? So round 2 will start and we'll mark again 1 and 6, 2 and 5, 3 and 4. So we have, right? So this time 2 and 5 we have, so 2 will win, right? Then we have 3 and 4, so 4 will win, right? So you know who will discard? This 5 will be discarded and this 3 will be discarded, right? Means 5 and 3 gone. So who left here? Now lineup becomes is 1 2 4, right? Because 2 4 is there and 1 is also win, right? In this we have either will win 1 or 6, God knows, right? So we think that 1 we have a win, right? So the next will become what? 1 2 4. Okay, when the next round will happen, right? So we'll go with 1 and 4. 2 will go to the advance because this is middle one, right? So here 4 will win, we know that, right? And that is the win, right? So if we'll do the round up, right, we'll say 2 and 4, and this is round 3. So we'll put into the array that 3 we have win, right? In the next round we have 2 and 4, so they finally meet each other, right? So this path they meet in the round 4, right? Means 3 and 4, that we can say, right? So but they can meet earlier. Can we meet earlier? Yes, right? Suppose other matches go differently. Maybe 2 and 4 lands in opposite ends of the line earlier, right? So let's look at another possible simulation. Like in this case, the winners for the first round outcomes are 2 4 and 6. God has changed the mood, right? And this time we have got 2 4 and 6, right? So round 2 will happen with the 2 and 6, right? Advance will happen with 4. Now who wins? 2 wins. Now line up 2 and 4 will come, right? Then 2 or 4, who will win? They meet again here, right? They can win anyone. In this case, they meet in the round 3, right? So we can say the final answer for the input, this one, is 3 and 4. They meet no earlier than 3 because they come to the 3 again, right? So there is no chances. Either God will try to do this game in their way, but the outcome will come 3 and 4. So they meet no earlier than the round 3, and so no later than round 4, we can say that. Okay, and that is why the answer is 3 and 4. I hope you understand, right? So what are the concept we are going to use in this problem, right? So we know the concept is player face off from ends, right? Like 1 vs n, 2 vs n minus 1, like that we have given, right? And the strongest players always wins here, right? Let's suppose the first player and the second player, when they face each other, right? What's you compute, right? That we can say. So the return format will be the earliest round and the latest round. Can we say that, right? So what is our intuition? Our intuition is that we have given n players, we have given, and two best players we have given, first player and the second player, and we have to return the earliest round and the latest round where these two meets in the tournament. And so what is our intuition, right? So match rule we have given it, like each round ith player vs n minus 1 plus 1th player, we can say that we happen if odd players are coming, middle player automatically advances and winner go to the next round. And then we have to do resorting again, right? Like by the player, and we'll repeat these things, right? So the strongest player guarantee that player first and player second are guaranteed to win against any other except each other, right? So problem simulation is we must simulate all the possible match outcomes for the remaining players, and as long as the first player and the second player doesn't meet, right, they both survive to the next rounds, right? So the random outcome for the others, we can say that when two normal player plays, right, let's suppose for not for first and second, they can be anyone else, right? So either can win, either anyone can win, right? We can say apart from the top players, our top players, right? We can say the strongest player. So we must consider both cases, we have to consider. So we have seen, right, n is equal to this, right? So example, so we simulate multiple paths. Let's suppose in some path they meet in round 3, in some path they meet in round 4, right? We have seen that, we have seen in they meet in the 3 and they meet in the 4, right? We have seen that, right? So we have to find what minimum round and the maximum round where they can find each other in the fight. So our approach, what we are going to use, we will use DFS and memoization, right? And memoization, we can say, to simulate all the valid tournament outcomes, right? So it will not repeat again and again. So the repetition calls will not go again and again. You can understand what is happening here, right? Let's start with all the players 1 to n. At each round we will make a pair players, and first and last, we can say, and so on, like that. We know how to make the pairs. We know the strongest player always wins if the match with normal ones, right? If strongest players face each other, will return the round count, and then recursively DFS will apply for every possible match between two normal players, explore both outcomes, either one wins, right? After all the winners are chosen, sort them and move to the next round. Then we'll do memoization, right, where we can memorize this data, like what is the outcome is coming, right? That will cast all the players, first index, second index, like that. We'll do player list, first index and the second index, we can say, and we'll avoid the recomputation with the help of memoization, right? And we'll track the result for every valid path where the first and second player meet, right? So we'll record it. So let's suppose earliest round will take mean and latest round will say max. Can we say that? It's very easy. You have to start with the plan 1. Let's suppose we'll call step 1. We'll start with all the players 1 to n. At each round, right, we have to make what? Pair players, right? You know how to make it. Then the strongest player, we know that they always win if they will play with the normal one. If the strongest player play with each other, we will return the count, right? Then we have to do recursive calls, right, with the DFS, like for every possible match between the two normal players, we explore both outcomes, either A will win or B will win, right? Either one wins, right? That case we will take, and after all the winners are chosen, we'll do the sorting, right? Because the cases are there, we have to explore the path for each one, right, each player, and that is why it become recursive, right? And so we have to do with the DFS. After all winners are chosen, right, we'll sort them, okay? And then we have to move to the next round. So you will say, how do you understand that this is DFS, right, and this is recursive? Because you know, the match will happen with 1 and 2. The possibility is that either one will be win and 2 will win, right? So for n number of people are there, then there is chances is n into 2 times we have the chances, right? Can we say that? and for only 2 I'm saying. If there is so many people are there, 2 to the power n to the power 2, we can say that, right? Possibilities are there. So we have to use the recursion and we have to save the memorization, so we'll avoid the recomputation again, right? So we'll cache player list, first index and the second index. And how we have to track the result? We have to take the mean and max, right? And we have to for the every path. I hope you understand, right? So how does this work, right? Because we have only 2 players that are fixed winner, right? And other matchups are flexible. So we will simulate all possibilities. Eventually the 2 strongest player must meet and we must have to find when, right? So what are the data structure that we are going to use, right? So for the recursive backtracking, we will use DFS, and we'll to store the sub problem results, we will use memoization, where we will use the map, and string and int, we'll take the int array. Okay, and we have to store each round player list, so we'll take the list. I hope you understand, right? So let's do some hands dirty with the code. So as we know, we will create the memoization cache, so that we will have the memo map, right, where we will store the string and integer array, right, that we have discussed. Then we'll create a function, right? This is the function that we have given. Let's suppose we have given n number of players, the first player and the second player, the top 2 strongest player we have here, player 1 and player 2, right? So we'll do what in the very next step, what we need to do we have to normalize the first player and the second player. Let's say we'll ensure the first is less than the second. Can we say that? So we'll check if first player is greater than the second player, right? So we'll store here the temp and we'll store like this. Okay, so the temp will store the here and the will, you know, the swapping, right? So we'll do the swapping here for here. Okay, then in the next step we'll start the DFS with the initial player list from 1 to n, where we have the list of players. We can say we'll create a list of players and we'll store the player number in this list, right? So for all the players we have to go for the loop I equal to 1 to n, and we'll store all the player in the list, you can say player list. Then we have to do the recursive call with the, we have to pass the players, first player, second player, and we'll start with the round 1. Okay, now understand, this is very important because all depends on this function, right? So this is our DFS function that simulate each round. We'll go with the each round. Now you have all the players, you have, you know, the first player and the second player, and you know that this is the round 1, 2, 3, 4 and so on, right? The very first we'll check if the first and the second are matched, we'll return this round, right? So if we'll find, let's suppose we have n number of players we have, we'll go with the half of the player, right? We know we have to make the pairs, so we'll go half of the player. Let's suppose 10 player we have, how many pair will be happen, right? 5 pair will be there, right? So we'll start from 0 to n by 2, means we'll divide the half of the player, because 2 pair will become 1 and 2 players, right? So we'll check if the condition match. Let's suppose player gets at I, get at I, you know, the array list, right? So array list have a method, get method, from where you can pass the I, you can say, and you can get the value. Okay, you have to pass I means index. What is the index at I? So at index at I, let's suppose this is the first player we have found the player is the first player, and we have, because why we are using the array list here, let's suppose. So array list contains we are adding here what we have, give me 1 second here. So here we have used array list because, you know, the order is 1 to n, right? Means order should be maintained, right? And we know the array list will preserve the insertion order, right? Means at index 0 what we have, index 0 is player 1, index 2 is player 2, right? Like that we can say. Can we say that? So we know that the list will contain like this. Okay, where was we? Here. Okay, so we'll check at index 0 if this is the first player, right? Means that first player will find. Then we'll say pair next player will check, the second last player will find from what, n minus 1 means we are going with the index 0, right? So what we will do, n minus 1 will do 1 minus left, which index is less, right, with the 1. So we'll do, and then we'll do minus I. So we'll check if this is the second player, if the first and second player there, or the second player and the first player, just reverse it, right? If any of them, just return the round. We will not do anything in the first round itself. We meet the player have made, as we have seen in the example. So we will return it. I hope till you don't have any issue, right? Then we have to generate the memo key, and we have to check in the cache. How we are going to do that? Let's suppose call it key string, and we'll get from what, players.toString, right? So players.toString we have means toString is used for string representation, right? So we have the player list, and from the player list we want to create a what we call toString. So either you, so it internally what will happen, let me show you how to do. So let's understand this what we call toString, what we are doing here. Okay, so we can say what is this toString, right? So toString is a method, we can say, that is available in every object class, right? You know the Java, right? So Java having a parent class, you can say parent of all the classes, right? You can say a grandfather of all the classes, right? So this class, object class, contains toString method, right? So this toString method is available on every object in the Java, because if the father have a car or any property, the object will also have. So if any class you are writing in the Java, so it is a child of this object class, you know that, right? So object class having almost, I think, 11 methods we have. I think one method is deprecated. So after the 11 method, the toString is very important, right? So this toString internally overrides we can say has code, right? Has code. So it will represent the code in we call hasing function, right? And then it will represent in the string. So little complicated I'm saying, because if you are not aware with this, is very difficult for you to understand. Okay, so let's suppose the players we have. So we'll let's suppose player we have, can we say that, how we can say that, let's suppose, yeah, let's suppose we have arrays, right? And we'll say as list, just I'm converting, just think that we have 2, 4 and 6, this we have given. Okay, so if we'll say this is our list of what, list of array we can say, and this is a integer, can we say that? And this is called players, players equal to this, can we say this is list, like array list, and this is integer, and this is player list. Give me 1 second. Okay, I hope you understands. And arrays dot as list will pass this value, right? So if we will let's suppose we'll do what, list dot toString, then what will come, it will come in the string format, that is called 2, 4 and 6. I hope you understand, right? Means the toString method will convert this list into string format, as simple as we can say that. Okay, and rest of them you see the I'll update in the comment what is the toString. I'll refer the things. I don't want to make this video too much big, right? So this will make you can say toString, then we'll add this key, right? So let's suppose the round is there, 2, 4 and 6 is there, right? After this we are appending this with the round, so we can say we'll take like this and we'll say round 0, right? So this will become your as a key for each round. So next round we'll have this key is, let's suppose 2, 4, 6 is we have, just you can remove it also, some of the element. Okay, we'll say round 2 is there, round 7 is there, round 8 is there. So these are the possibility that we can make the key like this. Okay, so why we are doing that, you will say why we are creating the key. So you know the has map, Has map contains key and value, you know that. So each key should be unique, and that we are doing here. Okay, so whenever a new round will happen, we'll append this round, right? And you will get round 1, round 2, round 3, like this, and each round having its value. Okay, where, and this is your nothing but your memoization table, right? A memoization map, we can say. So if we'll have, let's suppose key, I'm writing just for example 101 we have, and here is some data is there, let's suppose India, and we say that, and 102 we have USA, right? Like this. So if memorization, if anyone is going to find on this, the key is there or not. 101, yes, that is India. If 102, yeah, USA. Like this we will find on the memo table. I hope you understand, right? Now we have to try all the combinations, right, for all the winners, that is who is a valid one, right? So we'll take list of integer and we'll say next round, who will go in the next round, right? So all the list will take, this list contain a array of, we call players, right? Like this. And so we'll represent this also as a list of integer. Can we say that? And that is why this list of integer is this a player, and this is the list that will contain many lists like this. Sorry, this is single array, 1D array, we can say, like this. So at each round you will have the player list, right? So this list is nothing but your this list. Next round, so round 1 will contain this, round 2 will contain this, round 3 will contain like this, 1, 2 and 3, like this it will contain, right? This is called rounds that we will generate and will store all the player list. So each round will contain what we call player list, right? So as you can see, we'll generate the next round, we'll pass player, we'll start with the 0, and then pass what, new list will pass. Okay, next round first and second player will pass, we'll find the mean and max, right? And we'll then as we understand mean and max, so when we'll return it, we'll pass the mean and max. Okay, so each round we will go through this and we'll say, let's suppose we have the, in the next round we have some players list we have, right? We know that these are the players we have. So first of all we'll do the sorting in the next round also, right? And then we'll do recursive call again, just will increase round 1 plus this, so it will go to the parent DFS that we have seen, right? Initially it was 0, just from 0, next round is 0 plus 1 is 1, next round is 2, like this. We'll pass this DFS, we'll repeat the same thing, we will repeat again, right? And you will find the max and the mean, how, with the respect of what we get from the here, right? And finally you will, if everything goes well, we'll add into the memoization table, memoization map, and this is your mean and max. Once the key already here, we found this map, right? Oh, this key is already available, we'll return from here, means we will get this value. You know, we are putting on the key, we are what we are putting as a new array, we are putting is this array is mean and max. Can we see that? So we will return it. I hope you understand. If still have any issue, any doubt, right, please let me know in the comment section. Okay, so what happened? Okay, now let's understand. So we have seen n equal to 5, right? And first was 1 and second was 5. So this was the first one example. Let's so we'll do lineup, we'll check the pairing 1 and 5, and they will face immediately, right? So that is why in the very first step, right, we have seen that if both will give me 1 second, if both will meet, right, let's suppose 1 and 5 will meet, right? So immediately we'll return here, and that is why we have created the logic here. Where it was be here, right? Very first we'll check if both are meeting in the first round itself, we'll return it directly. Okay, as you can see this one, and rest of the thing will go with the generating the rounds, right? You know how to generate the rounds. This is the generate rounds method, right? This is the generate mode. We will pass the player I, like this will pass, current and result, and we'll go through all of them again. We'll generate the player list. You know how to do that. Let me explain you. Okay, I'll put the code into the comment section. So we will generate like this, right, each time. So each time we'll generate the next round, right, and you will have the player list, right, each time. So we'll follow like this, right. We'll for the middle player will automatically add into the player list for the next round, and rest of the thing, who will win, we don't know. So we'll generate all the cases will generate. Okay, so for the time and space complexity, it will take O of n square to the power n, as we told you, I told you, right. And for space complexity, we will use the cache memory n to the power 4. Okay, so thank you guys. If you have any doubt and any issues there, let me know in the comment section, right. Let me go through the code, right. First of all, this is the given method we have, right, and internally we are calling the DFS method. So you will implement this DFS method, right, correct. You will implement the DFS method. In this method, you are generating the what you call the for the next round, what are the players are there, and the two combinations, either A will win or B will win, right, like that we will check. Okay, and if the player is in the middle one, will directly add into there. Otherwise we'll take two players, player A and B, right, and we'll check who will win, right. If either of these is first, or A is first or B is the first, you know who will win. If we'll check the A is second or B is second, you know who will win. The first will win or second the will, right. And these are the other conditions that they can win, both can win, right. So normal cases we can say A will win and B will win, like that. Okay, that's all. Thank you guys. Thank you for watching this video. I hope you will enjoy this video. Thank you. Please like, subscribe the channel, and also share with your friends. So directly and indirectly you will support Expert Funda, and the Expert Funda will grow, and you will get the premium videos like this. Thank you guys. Thank you for watching.